let me whisper a question into the quiet between your headphones and the night. What if Mars is the obituary of a planet that once looked suspiciously like home? Not a fairy tale with green men and crystal domes, but a biography. Oceans, weather, chemistry, time, and then something went wrong. The red world we see tonight, the one that glows like a coal in the campfire of the sky, might be a photograph of Earth's bad future sent to us from a few billion years ahead. Tempting, isn't it? The idea clicks like a puzzle piece you didn't know was missing. Mars as a dead Earth. Now, before we gallop into the desert with flags and answers, let's talk about the two wolves that live inside every space story, romance and science. Romance says, there was a civilization there, NASA knows it, someone airbrushed the ruins. Science says, let's take a breath, run the numbers, test the rocks, and then decide. I'm not here to pinch the candle of wonder. I'm here to cup my hand around it so the wind doesn't lie to you. You've seen those headlines creep into your feed at 2 a.m. Ancient Martian cities, faces on mesas, secret archives. The conspiracy is delicious because it flatters us. If truth is hidden, then we are brave for seeking it. But history, both on Earth and off, rarely uses capital letters and neon signs. It speaks in silt and isotopes, in patterns that only emerge when you stack one careful measurement on another. You don't unmask Mars with a single zoomed image. You unmask it with patience, with dozens of robots playing geologist in slow motion. So here's our pact for tonight. We will keep the romance because people do not cross oceans for spreadsheets alone. But we will let science drive the car. We'll laugh, speculate, reach for metaphors, sure. We'll also carry a notebook. Because if Mars is a mirror, we want it to reflect more than our own wishful thinking. Start with the itch we can't stop scratching. Why Mars? Why now? Look around the 21st century like it's a spaceport departure board. Agencies, alliances, and private companies are stacking itineraries to the same destination, as if a whistle blew and everyone sprinted down the same corridor. The reason is not just a billionaire's mood or a movie's box office. Mars sits at the bright intersection of two human hungers. The oldest one, are we alone? And the newest one, can we live somewhere else if we must? It's near enough to reach with courage and fuel, alien enough to demand our best engineering, familiar enough to trick our hearts. And Mars has a habit that makes explorers grin. It keeps leaving breadcrumbs, dry riverbeds that wiggle like snakes frozen in sand, fan-shaped deltas that look like the handprint of water, minerals that, on Earth, prefer a drink. Even the length of the Martian day feels like a nudge. 24 hours and 37 minutes, a cosmic joke about hitting snooze. You can see why the red planet rents so much space in our imagination. It's the neighbour who looks like us in old photos but won't answer the door. This is where the rumours invade. If there were once oceans, the whisper goes, there were boats, then cities, then secrets. Someone must be hiding the evidence, but think of the scale of that accusation. We can't hide a pop star's breakup for 12 hours. You expect a scattered species with different languages, budgets, and politics to maintain a flawless, decades-long silence about statues on Mars. If anything, space agencies are guilty of the opposite vice. Press releases with confetti cannons over molecules that require 5 footnotes. You'll see that pattern in our story. Careful claims, then headlines that sprint ahead, then scientists tugging them back by the sleeve. Still, let's not disinfect the romance out of this. Half our achievements began as unreasonable daydreams. When Galileo pointed glass at the sky, he didn't know he was tuning an instrument that would one day chase dust in another world's sunset. When we say, was Mars a dead Earth? We're not only asking about Martian climate, we're asking a parental question. What went wrong? And how do we keep our child, Earth, from repeating it? That is the soft heartbeat under every graph you'll see in this story. Here's how we'll walk the desert without getting lost. First, the physics and the bones, size, air, gravity, heat. Then the scars, volcanoes the size of countries, canyons so wide they look like the planet yawned. After that, the old weather report, ancient water, where it pooled, how it moved, what it left behind. We'll open the sampler tray from our mechanical field geologists, those patient rovers scraping and sniffing. We'll talk about organics, the word that launches premature celebrations, and about methane, the gas that behaves like a rumour, appearing, vanishing, contradicting the instruments that try to catch it. Somewhere along that path, we'll meet the celebrity scandal of planetary pareidolia, the face that launched 1,000 cable shows, and explain why our brains are both priceless and untrustworthy witnesses. Later, we'll let the wilder dreams in, because doorways deserve to be opened even if there's a broom closet behind them. Terraforming, for instance, the audacious plan to warm a frozen world until it exhales. We'll examine it with the same generosity and rigour, the CO2 ledger, the missing magnet, the bills that make governments nervous. We'll also step into the mundane heroism that's more likely, little Earths under domes, crops humming under artificial suns, the treadmill that saves your bones when gravity has left the room. If the grand renovation doesn't happen, could a string of bright villages across the desert be enough? Perhaps the future is a quilt, not a cape. And throughout we'll thread a second, quieter story, how Mars changes us without moving an inch. Every discovery there is a lesson here, about atmospheres that vanish, climates that tip, and the fragile, generous luck of our magnetic bubble. If Mars is a message, it may not be come live here. It may be respect the improbable home you already have. So, no answers yet, a promise instead. We'll stand on the ridge between myth and math, with patience as our compass and curiosity as our canteen. We'll keep the jokes dry and the claims wetter than clickbait. And by the time we step off this first dune and down into the valley of data, you'll be ready to judge the rumours for yourself. Was Mars a dead Earth? Or is that just the story we tell because we like seeing our own reflection in other people's windows? Keep walking. The wind is picking up and there's a riverbed ahead that isn't supposed to be there. So why now? Why this sudden planetary crush on Mars? Let me put it like this. If the solar system were a neighbourhood, Mars would be the quiet house 2 doors down that everyone suddenly wants to break into. Partly because the curtains are drawn, partly because once, long ago, someone swears they saw a swimming pool in the backyard. The 21st century has turned into a Mars stampede. NASA sent its bulldog rovers to sniff the soil. Europe and China pack their own missions like neighbours bringing casseroles to the same dinner. Even the United Arab Emirates got in on the act with their Hope orbiter, because apparently it isn't enough just to sell oil, you've got to check out red rocks too. And then there's Elon Musk tweeting like a modern-day conquistador, promising to turn Mars into Plan B before we've even figured out Plan A for climate change. But don't be fooled, this isn't coincidence. It's not even just about the romance of Next Frontier, it's about biology, politics, and survival. Mars is the best laboratory outside of Earth for answering humanity's most awkward dinner table question. Are we alone? Think about it. Venus is a death sauna. Mercury is basically a ball of metal frying too close to the sun. Jupiter's moons might be juicy, but they're buried under kilometres of ice. Mars, by contrast, is right there, relatively close. Reachable in a few months with rockets we already own, and best of all, it left us geological breadcrumbs, channels, deltas and minerals that whisper about water and therefore about life. Now let's pause and appreciate the sly genius of evolution here. Humans are dopamine addicts for patterns. Tell us there might have been oceans on Mars and we immediately build imaginary sailboats and civilizations in our heads. The scientist says, sedimentary rock indicating past fluvial activity. Our brain translates mer people. But behind the clickbait headlines and conspiracy theories, the sober truth is enough to make even a jaded grad student sweat. Mars is the only other rock in the cosmic cul-de-sac that plausibly could have nurtured life. If that isn't worth a few $1 billion and some space robots, what is? And the stakes are bigger than curiosity. Mars is more than a cosmic what-if. It's also the closest thing humanity has to a lifeboat. If Earth catches a terminal case of climate change, nuclear tantrums or asteroid roulette, then Mars is the only option that doesn't require warp drive. It's not Plan A, we should still fix the kitchen fire before running to the neighbours, But Plan B keeps us from sitting in the flames pretending everything's fine. So, why now? Because our technology has finally inched far enough ahead to make the gamble seem less like madness. Because national pride still burns, and nobody wants to be the country left watching while someone else plants a flag. Because billionaires are restless and space is the new luxury yacht. And most of all, because every time we look through a telescope or a rover's camera, Mars winks at us with that maddening dusty grin that says, "I may have secrets. Come and see." The hunt has begun, and it's not just science, it's competition, myth, and survival braided together. Which brings us to the next question. If Mars is the house down the street, how close is it really? What's it like as a neighbour? Let's knock on that neighbour's door. Mars is close enough to tempt us, far enough to punish us. In space terms, it's basically next door, roughly 55 million kilometres at its friendliest, which granted makes borrowing a cup of sugar take about 6 months of travel time. But in cosmic geography, that's not bad at all. It's like living in the same city, compared to Jupiter's moons, which might as well be in another country. Now, here's where it gets deliciously eerie. Mars runs on a day that lasts 24 hours and 37 minutes. That's practically a cosmic copy-paste of our own routine. Imagine the first astronauts there, jet-lagged not by time zones, but by 37 extra minutes that quietly stretch every single day. Picture the coffee machine at the Mars base. You're allowed 1 cup at 9 a.m, Mars Standard Time. But when exactly is 9 a.m. if your watch keeps slipping by half an hour each day? Even small details like this matter, because circadian rhythms, the internal clocks that dictate when we sleep, eat, and snap at co-workers, are tuned to Earth. Mars is just close enough to make us hopeful, just odd enough to mess with our biology. And here's the kicker. The seasons. Yes, Mars has seasons. Winter, summer, spring, fall. Thanks to its tilted axis, just like Earth. But don't get too excited. Martian winter isn't sweater weather. It's your face freezes in 10 seconds weather. Still, the fact that Mars even bothers with seasons makes it feel like a cousin rather than a stranger. If you zoom out, you begin to see why explorers can't let go of this place. It's alien, but not hopelessly alien. Culturally, this is where human imagination runs wild. For centuries, we've projected our own struggles onto Mars. When 19th century telescopes showed faint lines on the surface, Italian astronomer Giovanni Schiaparelli called them canali, channels. The English press, hungry for drama, mistranslated this as canals. Suddenly the world thought Mars had engineers digging aqueducts across a dying world. Newspapers printed maps. Sci-fi writers went feral. The Martians of H.G. Wells' War of the Worlds were born from that slip of a pen. All because the planet seemed just close enough to us that we expected intelligence to live there, struggling, surviving, building canals like ancient Romans. This is the double-edged sword of Mars. Proximity feeds myth. Too far, and it would be a cold rock like Pluto, ignored except by grad students. Too close, and we'd know it's barren. Mars sits perfectly in the uncanny valley, near enough to tease, strange enough to intrigue. And from a practical angle, its closeness means missions aren't just thought experiments. With our current rockets, a one-way trip takes months, not decades. That makes it possible, in theory, to send cargo ahead. Then humans after. It means politicians can actually imagine a Mars mission within their careers, and billionaires can fantasize about selling tickets while still alive. The space race of the 1960s was about flags and bragging rights. The Mars race of the 21st century is about survival, science, and, let's be honest, branding. So Mars is our almost twin, a neighbour with the same day length, a familiar spin, recognisable seasons. Yet it's also a neighbour who hasn't watered the lawn in billions of years, whose house is falling apart, whose air is thin, and whose backyard is littered with dust storms. And that's the contradiction that drives us crazy. Close enough to dream about, dangerous enough to remind us we're still soft earthlings. Next, let's peel back the polite introductions and look at the bare bones. The raw data of Mars, the measurements, the numbers, the kind of things that would make an engineer nod and a romantic wince. Because to fall in love with Mars, you first have to see how harshly it greets its visitors. All right, romance aside, time to look at Mars without makeup. Strip away the myths and conspiracy theories, and what do we see? A planet with stats that read more like a death wish than a holiday brochure. First, the size. Mars is about half the diameter of Earth, roughly 6,800 kilometers across. If Earth were a basketball, Mars would be closer to a softball. Cute, maybe, but don't let that fool you. Small size comes with small gravity, about 38% of what we enjoy here. On Mars, you'd weigh 1/3 of your Earth weight. That sounds fun until you realise your bones and muscles would throw a tantrum. Long-term, weaker gravity means brittle skeletons, weaker hearts, and astronauts turning into fragile humans who can't go home without years of rehab. Jumping higher isn't quite as cool if your femur snaps after a year. Next, the air, or rather, the lack of it. Mars's atmosphere is whisper thin, with a surface pressure only 0.6% of Earth's. Imagine standing on top of Mount Everest, gasping in the thin air. Now multiply that feeling by 15. Without a pressure suit, your saliva would start to boil before you even froze, and freeze you would, because Mars is cold. Bitterly cold. The average temperature hovers around 63 degrees. At noon near the equator, you might see a balmy 0 degree, but nightfall will drag you down to 100 degrees faster than you can zip up your spacesuit. Mars doesn't do cozy evenings. And what about the recipe of that thin air? 95% carbon dioxide, a sprinkle of nitrogen, and barely a whiff of oxygen. Less than 1/10 of 1%. Enough to keep plants alive if you build them a greenhouse, but not enough for you to stroll around taking deep breaths of Martian morning air. Unless you enjoy suffocating, it's not just the numbers that sting. The atmosphere also means poor insulation from cosmic punishment. On Earth, our thick blanket of air plus a magnetic shield keeps us relatively safe from solar tantrums. On Mars, that thin veil lets in ultraviolet light and cosmic radiation like a broken umbrella in a storm. It's not just cold, it's naked. Even the ground fights you. Martian soil is laced with perchlorates, nasty salts that are toxic to humans. Great for rocket fuel, terrible for salads. Every grain of dust you breathe in could shred your lungs, and every step you take could bring poison into your base. Imagine sweeping your kitchen floor knowing that dust can corrode your electronics and poison your bloodstream. That's Mars in a nutshell. And yet, this is where the irony cuts deepest. These brutal stats, this anti-life CV, are exactly why scientists are obsessed. Because if Mars once hosted water, rivers, maybe even life, then something catastrophic happened to erase it. And understanding that catastrophe isn't just planetary gossip, it's a warning label for Earth. So Mars is small, cold, poisoned, and suffocating, yet it's also irresistible. Like a bad ex we keep texting at 2 a.m, even after swearing we'd move on. And the deeper we look, the more seductive details we uncover, like the strange red veil that covers its sky. That's our next stop. Why the heavens over Mars are painted in rust, and what that says about the planet's story. Let's lift our heads from the dust and look up. On Earth the sky is blue because sunlight scatters off the tiny molecules in our thick atmosphere. On Mars, the sky is blushing, pinkish, orange, sometimes a deep rusty red, as if the whole world is stuck in a permanent sunset. Why? Because the air is full of iron-rich dust. Mars has a lot of iron in its soil. When rocks break down over billions of years, they release fine particles laced with iron oxide, what we'd call rust. Those particles don't just sit politely on the ground, they ride the wind, and once airborne, they scatter sunlight in a way that turns the whole sky a pale salmon. Imagine living on a planet where every day feels like the golden hour for photographers. Romantic at first, maybe, until you realise the glow is caused by toxic, choking grit. And Mars doesn't stop at gentle haze. Sometimes the winds whip up into monsters, dust storms so vast they swallow the entire planet. One storm in 2018 wrapped the globe for months, choking out the light so thoroughly that NASA's beloved rover Opportunity went silent and never woke up again. Picture that. An entire world wrapped in a swirling orange veil, like a cosmic sandstorm frozen in place. Beautiful, deadly, final. What does it feel like? Think of stepping outside and watching the sky turn into a fiery watercolour painting. It's gorgeous, until you remember that every brushstroke is made of razor-fine grains of rust. Drifting into your lungs, scouring your equipment, scratching your helmet. On Mars, beauty always comes with a knife behind its back, and there's another trick here. Sometimes the dust plays games with light. At sunset, instead of the red glow we know on Earth, the Martian horizon glows a cold blue. It's the opposite of home. Red days, blue sunsets. A reminder that familiarity is always dressed in disguise when you travel beyond Earth. This isn't just trivia. That ever-present dust is a clue to the planet's history. It tells us about the chemistry of the rocks, the lack of rain to wash anything clean, the long silence since Mars had weather like ours. Each grain is a time capsule from an older, wetter world, powdered and blown across the surface. Every time a rover wipes its solar panels, it's brushing off billions of years of planetary memory. And here's the darker whisper. Those storms, that dust, that thin reddish sky, they're the scars of a lost shield. Because once upon a time, Mars had more than this. It had thicker air, maybe lakes, maybe oceans. Then it lost something Earth still has, a magnetic heart. That missing shield is our next chapter. Now, let's talk about the missing shield, the invisible armour that Earth wears proudly, but Mars misplaced a long time ago. On our planet, molten iron churns in the outer core, spinning like a cosmic dynamo, and that motion generates a magnetic field. It's our planetary force field, pushing back solar wind, deflecting cosmic radiation, letting us live without being cooked or stripped bare. Without it, Earth would be bald. No air, no oceans, no ozone, no beach vacations. Mars. It had a dynamo too once. Billions of years ago its core was alive. Heat moving, metal swirling, field humming. The rocks prove it. Patches of crust still carry ancient magnetization, like fossils of a vanished defense system. But Mars is smaller than Earth, which means it lost its internal heat faster, like a mug of coffee that cools quicker than a cauldron. The dynamo sputtered out, the field collapsed, and suddenly Mars was naked under the sun. Imagine standing outside with no umbrella during the most brutal storm imaginable. Not rain, but particles streaming from the sun at hundreds of kilometers per second. Solar winds slammed into Mars, peeling its atmosphere molecule by molecule, a slow planetary undressing that took millions of years. It's not Hollywood drama with fire and explosions, it's erosion, relentless, invisible, patient. Today, satellites still watch this escape in real time. NASA's MAVEN mission caught particles bleeding from Mars like steam from a cracked kettle. It isn't just poetic, it's happening now. The red planet continues to lose what little atmosphere it has left. Mars is still dying, only in slow motion, and that magnetic collapse was the pivot point. With no shield, liquid water couldn't stay. Oceans evaporated or froze, the air thinned, the surface froze dry, and whatever chance life once had slipped underground or disappeared entirely. Mars went from young Earth's cousin to red desert with scars. This is the moment in the story where the lights go out. And yet, like any good tragedy, the ruins are hauntingly beautiful. You can see them in the monsters of Martian geography. Volcanoes tall enough to mock Everest, canyons wide enough to swallow countries. They're not just landscape, they're epitaphs. And that's where we go next. Let's walk into the Martian wilderness now, where the planet's bones jut out like ancient monuments. Earth has Everest, a proud peak at 8.8 kilometers. Mars laughs and raises you Olympus Mons, 22 kilometers tall, 2.5 times higher, sprawling like a continent-sized blister. If you stood at the base, the curve of the horizon would hide the summit. You could walk for days uphill and still not reach the rim. And the caldera at the top? It's so wide you could drop the entire state of Rhode Island into it and still have room for dessert. How does something like that even exist? Mars's weaker gravity let volcanoes grow without collapsing under their own weight, and the planet's crust didn't shuffle around with plate tectonics like Earth's does. So instead of moving, the same hotspot kept feeding Olympus Mons for millions of years, piling lava upon lava until it became the solar system's greatest mountain. It isn't just geology, it's excess. Mars doesn't do moderation. Now shift your gaze eastward and you'll find Valles Marineris, a canyon system so enormous it makes our Grand Canyon look like a paper cut. 4,000 kilometers long, up to 7 kilometers deep, stretching across a fifth of the planet's circumference. Imagine a scar that runs from New York to Los Angeles and keeps going until it hits the Pacific. Scientists think it began as a crack when the Martian crust stretched, then was widened by landslides, erosion, maybe even water. Stand on the edge and you'd see cliffs disappearing into haze, shadows swallowing sunlight, a view so vast your brain would need new vocabulary. And it doesn't stop there. Mars is pockmarked with craters like acne scars from a violent adolescence. Some are fresh, sharp-rimmed, others softened by wind and dust, all reminders that Mars has no thick atmosphere to burn incoming meteors. Every rock that wanted to leave its signature found a blank page here. But perhaps the most tantalizing shapes are the weird ones, the mesas and ridges that look almost designed. A hill shaped like a pyramid, a rock that, in low resolution, resembles a face. These are the ink blots where our imaginations run wild. Natural formations, yes, but when you squint at a photograph from millions of kilometers away, shadows can trick your neurons into whispering civilization, and so myths were born. Still, even stripped of fantasy, Mars's landscapes are unlike anything on Earth. They tell a story not just of violence, but of a planet that once had energy, heat in its belly, water on its skin, winds carving sculptures. Every canyon, every volcano, every crater is a page in the Martian diary. And when we flip through those pages, the theme is clear. This was a planet that once had potential, then lost its script. The next chapter? We follow the water. Because wherever you see channels and valleys, you see the ghost of rivers, the memory of oceans, and perhaps, just perhaps, the cradle of life. If Mars is a graveyard, then water is the ghost that still lingers there. Every mission, every rover, every orbiter has one obsession: follow the water, because water is life's shadow. Wherever it flows, it leaves footprints. The first whispers came in the 1970s. When scientists studied the Viking orbiter images, they gasped. The surface of Mars wasn't smooth and barren, it was carved by something that once moved. Valleys stretched for hundreds of kilometers, meandering like frozen snakes. Tributaries branched into deltas, their fingers pointing toward vanished lakes. And some regions showed what looked like ancient coastlines, gentle arcs and boundaries that resembled the edges of oceans. Mars looked like it had cried rivers, bled floods, and maybe even cradled seas. Think about that. For billions of years, humans stared at Mars with naked eyes and saw only a red dot. Then suddenly, a machine in orbit revealed scars of rivers wider than the Mississippi, channels longer than the Nile, floodplains bigger than entire countries. Not imagination. Not conspiracy, geology. More evidence poured in over the decades. Orbital spectrometers found minerals that only form in water, clays, sulfates, hydrated salts. It was like finding seashells in the desert, proof that the desert wasn't always dry. And when rovers rolled across dried-up lake beds, they confirmed it. Pebbles rounded by running streams, sedimentary layers stacked like pages in a watery diary. At Gale Crater, curiosity read those pages and found the tale of a lake that lasted millions of years, not a fleeting puddle. Mars wasn't just wet, it was persistently wet. Not just one storm or one flood, but entire eras of rivers and lakes. Some scientists even propose that a vast northern ocean once covered a third of the planet. Picture that for a moment. Waves lapping against Martian shores, tides rolling under a pink sky, rivers feeding into a sea. Not Earth 2.0, but something close enough to make you shiver. Of course, water didn't stick around. With the atmosphere thinning and the magnetic shield gone, surface water either froze into glaciers or escaped into space. But the evidence of its passage is undeniable. Every delta, every dry channel, every mineral deposit is a photograph in stone. Mars may be bone dry now, but once it dreamed in blue. And here's where the story sharpens. Because if there was water, and not just a splash but oceans, then life becomes a real possibility. Microbes could have swum in those lakes. Algae like mats could have lined those shores. Life may have taken root and then gone underground when the surface turned hostile. But before we dive into life, let's linger one more moment with the waters. Because beyond rivers and seas, Mars may have kept a secret ocean buried in the north. A world within a world. That's the next puzzle, and it's one that could change everything we think we know about dead planets. Now we leave the rivers behind and wade into something bigger. Oceans. Yes, entire seas may once have rolled across Mars. Not a trickle, not a temporary flood, but coastlines that stretched across the northern hemisphere. Scientists call it the Oceanus Borealis hypothesis, which is just Latin for there used to be a giant puddle up north, and we're still arguing about it. The case begins with topography. Look at a global map of Mars and you'll notice a strange divide. The southern half is cratered highlands. The northern half is smoother lowlands, lying 2 to 3 kilometers lower. That low basin looks suspiciously like a drained ocean floor. Add to that faint ridges and boundaries that resemble ancient shorelines, and suddenly the planet looks less like a desert and more like a crime scene where the water skipped town. Then came the radar. Chinese and European missions have found buried structures under the surface of these lowlands, layered deposits shaped like ancient beaches. In 2022, one study reported evidence of sedimentary fans and possible shorelines buried beneath northern plains, the kind you'd expect if waves had lapped there billions of years ago. Imagine standing on the edge of a Martian sea, under a salmon-coloured sky, while waves crash onto a coast made of rust-coloured sand. A cold, alien ocean, but an ocean nonetheless. Of course, the case isn't closed. Mars has a way of tricking us. Some of those shorelines might be tectonic features or lava flows. Without a magnetic field to hold a thick atmosphere, could Mars have even supported oceans for long, the skeptics argue? But the evidence keeps piling up. Delta deposits, buried sediments, minerals that only form underwater. Each rover and orbiter adds another piece. The scale of it all is staggering. If the ocean existed, it could have covered an area the size of the Arctic Ocean here on Earth. Why does this matter? Because oceans are stability. A puddle dries in a day. A river can calve for centuries. But an ocean, that's millions of years of persistent wet chemistry. Enough time for life to appear, adapt, maybe even thrive. If the ocean hypothesis is right, then Mars wasn't just Earth's cousin. It was Earth's twin, singing the same watery lullabies until the music stopped. And maybe, just maybe, the ocean didn't vanish completely. Maybe some of it retreated underground, locked away in frozen aquifers, waiting. Which means the next logical step is to look at the planet's detectives, the rovers who read the rocks like ancient manuscripts. That's where the story turns from global maps to gritty close-ups. Enter the detectives, the rovers. If Mars keeps its secrets written in stone, then these little machines are the librarians. They trundle across the dust, drill into rocks, and send back postcards of ancient landscapes. And one rover in particular has earned its stripes as the patient historian, Curiosity. In 2012, Curiosity dropped into Gale Crater, a basin the size of Connecticut, with a central mountain rising like a layered cake. From orbit, the crater looked suspiciously like an old lake bed. And sure enough, Curiosity found the evidence. Finely layered mudstones, pebbles rounded smooth by ancient streams, sediments stacked in quiet order. Not the chaos of a flash flood, but the rhythm of a lake that persisted for millions of years. Picture this. 3 billion years ago, Gale wasn't a dusty hole. It was a lake surrounded by gentle hills. Water flowed in through channels, depositing sediments that built up slowly year after year. Imagine standing on the shore back then. The air thicker, the climate warmer, ripples moving across a shallow blue-green expanse. Mars wasn't always a desert. It had afternoons that felt almost earthly. But Curiosity didn't just find water. It found habitability. The rocks carried the chemical ingredients life would need. Carbon, hydrogen, nitrogen, sulfur, phosphorus. Energy sources too. Minerals that microbes could munch on the way bacteria do at Earth's hot springs. In other words, Mars had all the ingredients on the recipe card. Whether the cake ever baked into life, that's another question. But the pantry was stocked, and Curiosity is relentless. More than a decade on, it's still climbing the slopes of Mount Sharp, reading the layers like chapters in a book. Each stratum tells a story, wetter periods, drier stretches, climates shifting over millions of years. From these rocks, we learn that Mars didn't just wink briefly with water, it had a climate that ebbed and flowed, a planet that lingered in habitability before tipping into cold ruin. Now, if Curiosity was the detective who uncovered the quiet persistence of water, its younger cousin Perseverance became the one chasing the loud finale, the drama written in the delta of Jezero crater. And that's where we're headed next. Because Jezero wasn't just a lake, it was a meeting place of river and basin, a place where evidence, if life ever existed, might still be preserved in stone. If Gale Crater was a calm diary, then Jezero is the scrapbook. Chaotic, layered, stuffed with the evidence of water's wild dance. That's why NASA sent its most advanced rover, Perseverance, to land there in February 2021. Not for the scenery, but because Jezero once held a river delta, and the kind of geological feature that acts like a memory vault. Deltas trap sediments, preserve organics, and, if you're lucky, fossilize traces of life. From orbit, the delta is obvious. A fan-shaped formation spilling into the crater, just like the Mississippi empties into the Gulf of Mexico. But standing there, well, as much as a robot can stand, Perseverance found more than pretty shapes. It discovered that Jezero had a long, complex watery history, layer upon layer of sediment, some calm and fine-grained from a stable lake, others coarse and jumbled from sudden floods. At one point, massive torrents carried boulders the size of cars into the basin, proof that Mars didn't just drizzle, it raged. But the quieter layers are the most tantalizing. Fine sediments deposited gently in still waters are perfect at trapping organics, and Perseverance has the tools to check. With its Sherlock instrument, yes, NASA really named it that, it scanned rocks and detected signals consistent with organic molecules. Again, not proof of life, but proof of chemistry that could support it. Imagine bacteria clinging to sediments billions of years ago, and their chemical fingerprints still glowing faintly under ultraviolet light today. And here's the truly historic move. Perseverance isn't just analysing, it's caching. Using its drill, it's collecting cores, sealing them in pristine titanium tubes, and dropping them onto the surface like little treasure chests. Future missions, the Grand Mars Sample Return Project, aim to fetch those tubes and bring them back to Earth. That would be a first. Instead of arguing over blurry rover photos, we'd have the rocks themselves in our labs under microscopes, probed by the best instruments humans can build. Think of it, a sealed stone, billions of years old, cracked open in a clean room on Earth, revealing traces of ancient Martian life. It sounds like science fiction, but the groundwork is already there, scattered in neat rows across Jezero's floor. So if Curiosity showed us that Mars could have been habitable, Perseverance is setting the stage to answer the more intimate question. Was it ever inhabited? And that brings us to the bigger picture, the water that still lingers today, hidden not in craters or deltas, but locked as ice and maybe as secret underground lakes. So far, Mars has shown us its past: rivers, lakes, deltas. But what about today? If you freeze the movie and look at the planet right now, is there still water? The answer is yes, but it's not what you'd expect. At the poles, Mars wears white caps, not made of snow the way you imagine on Earth, but layered stacks of water ice and dry ice, frozen carbon dioxide. In winter, the caps expand dramatically as the thin atmosphere itself freezes out, only to sublimate back into vapour when summer returns. They breathe with the seasons, waxing and waning like the lung of a frozen world. Under those caps, radar has probed thick layers of pure water ice, enough, in theory, to cover the whole planet in meters of ocean if melted. And it isn't just the poles. Beneath the dusty surface at mid-latitudes, orbiters have spotted evidence of buried glaciers, massive reserves of frozen water hidden just a few meters down. Think of it like an ancient deep freezer stocked with leftovers from Mars' wetter youth. A jackpot for any future colonists: just dig, melt, and drink. But the most tantalizing hints come from beneath the surface. In 2018, the European Mars Express orbiter used radar to detect a reflective patch under the South Polar ice cap. The best explanation? A pocket of liquid water, briny and salty enough to stay melted despite the freezing temperatures. It sparked headlines about Martian lakes and underground seas. Follow-up studies have debated whether those signals really mean liquid water or just unusual clays, but the possibility remains. And here's the deeper point. Liquid water might survive underground. Shielded from radiation, stable for billions of years. If Mars ever had life, this is where it could have retreated when the surface turned into a desert. Imagine microbes huddled in salty brines, like Earth's extremophils in Antarctic subglacial lakes. Out of sight, but not impossible. Of course, finding those hidden aquifers isn't easy. Radar can tease, but it can't drill. To prove it, we'd need to go down, meters, even kilometers. That's an engineering challenge no current rover can solve. But the idea haunts us. Mars may look dead on the outside while still carrying a faint heartbeat below. And if water is the stage, organics are the actors, because the next step in the hunt isn't just finding the solvent of life, it's finding the raw chemistry that makes life possible. And Mars has offered us those clues too. Now we step from water to chemistry, the real fingerprints of habitability. Because water alone doesn't make soup. You need ingredients, and that's where the word organics enters the Martian dictionary. Back in 2018, NASA's Curiosity rover made headlines when it dug into 3 billion-year-old mudstones and sniffed out organic molecules. Not biology, let's be clear. On Earth, organic might conjure kale smoothies or compost bins, but scientifically it just means carbon-based compounds, the building blocks of life, not the life itself. Still, on a planet long suspected of being sterile, finding even the scaffolding of life's chemistry was a jolt. These organics were ancient and stubborn, trapped in sedimentary rocks that once lay at the bottom of a lake. Complex molecules, surviving radiation and time, buried under dust until a robot with a drill unearthed them. That discovery didn't answer the life question, but it blew the door wide open. Mars wasn't chemically barren. It was a pantry with something left on the shelves. And here's where context matters. On Earth, organics rain down all the time, from life itself, from meteorites, from volcanic activity. Mars could have received its organics the same way, delivered by comets, cooked in volcanism, or, most excitingly, produced by ancient microbes. The problem is that all three leave similar chemical crumbs. A molecule doesn't come with a name tag that says, "Hi, I'm biological." So we're left holding the evidence but not the verdict. Yet the very survival of those molecules is telling. Mars today is bathed in radiation, an environment that tears organics apart. For anything to last 3 billion years, it must have been buried quickly, sealed by sediments, and protected underground. That means the places Curiosity explored, ancient lake beds, weren't just wet. They were geologically kind, places where evidence could linger. If you're a microbe trying to leave a fossil, that's the neighbourhood you'd want. The discovery changed the tone of Mars exploration. Before, the question was, could life ever have survived here? After, it shifted to, did life actually take the chance? Because Mars clearly had the right recipe: water, energy sources, and organics. What we don't know yet is whether the oven was ever switched on, and that's where Perseverance picks up the thread. Because in Jezero crater, it found more whispers of organics, preserved in rocks that once lay in the delta of a long-gone river. 2 rovers, 2 craters, 1 message. Mars still carries chemical echoes, but if organics are whispers, methane is a shout, and that gas is the next mystery. A riddle that has scientists scratching their heads and conspiracy theorists writing YouTube titles in all caps: methane. On Earth, it's a gas with an unglamorous resume: cowbirds, swamps, leaking pipelines. But on Mars, methane is headline material because methane is unstable. Once released into the atmosphere, sunlight and chemistry destroy it in a few hundred years. So if methane is floating above Mars today, it means something is making it right now, and that something could be geology or biology. The story begins in 2003, when ground-based telescopes caught a whiff of methane in the Martian air. Not much, just a few parts per billion, but enough to spark fireworks. Later, NASA's Curiosity rover confirmed seasonal methane spikes in Gale Crater. Imagine a gas that rises in summer, falls in winter, like a living breath. Then, just to make it spicier, Curiosity detected sudden plumes, bursts where methane concentrations shot up dramatically, then vanished days later. What could cause that? 2 suspects stand in the lineup. The first is geology. Certain reactions between water and rocks, called serpentinization, can produce methane without any microbes involved. Old organic materials trapped in ice can also release methane when thawed. The second suspect is life. On Earth, 90% of methane comes from microbes, tiny organisms digesting, fermenting, exhaling. If Mars ever had such microbes underground, methane could be their ghostly calling card. But here's where the mystery twists. In orbit, the European Trace Gas Orbiter, designed to sniff methane with extreme precision, found nothing. Zip. A contradiction. Curiosity reports methane spikes at the surface, but the orbiter overhead detects none. It's like catching smoke in your living room while the chimney inspector swears there's no fire. Scientists scramble for explanations. Maybe methane appears only locally, hugging the ground before breaking down. Maybe it's destroyed faster than we thought. Or maybe, just maybe, our instruments are looking at different times and places, catching a flicker that doesn't last. And that's what makes methane maddening. It's there, then it's gone. It teases, then disappears. Enough to fuel speculation, never enough to close the case. Even NASA scientists have admitted frustration. If methane is real, it could be Mars' loudest signal in decades. If not, it's the most elaborate mirage we've ever chased. But this isn't the first time Mars dangled a riddle. In fact, decades earlier, a rock from Antarctica nearly convinced us that Martian life had already been found. That story, equal parts triumph and embarrassment, would dominate headlines and spark one of the most heated debates in planetary science. The year was 1984, and Antarctica gave us a rock that would set the world on fire. Scientists found it in the Allen Hills, so they named it ALH 84001. At first glance, just another meteorite. But when geologists studied its chemistry and isotopes, they realized it had come from Mars, blasted off the planet millions of years ago by an impact, then wandering space until it crash-landed on Earth's ice. A literal Martian souvenir. For a decade it sat in collections, until in 1996 a team of NASA scientists dropped a bombshell. They claimed the meteorite contained evidence of life. Not big fossils, no trilobites in Martian amber, but tiny features that looked under an electron microscope, like fossilized bacteria. Along with odd magnetic crystals and organic molecules, the case seemed explosive. Here was the first proof that we weren't alone. The world went mad. Newspapers screamed, politicians congratulated, even the US president gave a televised speech about the possibility of life beyond Earth. It was a cosmic mic drop moment. For a brief time, Mars wasn't just myth, it was history in the making. But science doesn't stop with headlines. Other researchers stepped in, scrutinizing the evidence. The microfossils were too small, smaller than any life known on Earth. The organic molecules could have come from contamination or natural chemistry. The magnetic crystals. They could be explained by simple geologic processes. One by one, the extraordinary claims unravelled under the weight of ordinary explanations. ALH 84001 didn't prove life. It proved something else. How desperate we are to find it. How quickly excitement can blur caution. And how important skepticism is, even when the story feels irresistible. Today, the meteorite is still studied, still debated in fine detail, but most scientists agree it doesn't contain Martian microbes. Instead, it's a cautionary tale, a reminder that the line between discovery and wishful thinking can be razor thin. Yet the episode left a permanent mark. It showed us that Mars isn't just about rocks and dust. It's about psychology, politics, and hope. And sometimes our brains see faces where there are only shadows, which leads us perfectly to the next chapter, the infamous face on Mars, the optical illusion that fooled millions and became a conspiracy legend. July 1976, Viking 1, NASA's proud Martian scout, was orbiting the red planet, snapping photos for future landings, and then, there it was. In the Cydonia region, a grainy black and white picture showed what looked like a colossal human face. 2 eyes, a nose, a mouth, all carved into the Martian ground like some interplanetary Mount Rushmore. NASA, being NASA, shrugged. The press release called it a mesa, with shadows that happened to look like a face. To the scientists, it was a rock playing dress-up. To the public, it was fire on dry grass. Tabloids splashed the face on Mars across front pages. Talk show hosts speculated about Martian architects. Science fiction writers went into overdrive. Suddenly, Mars wasn't just a dead world. It was the ruins of a forgotten civilization. The theory spread like wildfire. If there was a face, maybe there were pyramids too. Some pointed at nearby hills arranged in geometric patterns, calling them the Cydonia pyramids. Others spun tales of a vast Martian city, abandoned long before humans walked the Earth. Authors like Richard Hoagland made careers out of the claim, writing bestsellers that accused NASA of covering up alien ruins. And the internet, when it arrived in the 90s, poured gasoline on the flames. But here's the punchline. When better cameras came along, the magic disappeared. In 1998, the Mars Global Surveyor revisited Cydonia with sharper eyes. The face turned into a lump of rock with a rounded top. By 2001, higher resolution colour images sealed it. Just a hill. No eyes, no mouth, no Martian Michelangelo. Psychologists weren't surprised. There's a name for this trick of the brain: pareidolia. It's the same reason we see Jesus in burnt toast, or animals in clouds. Our pattern-hungry minds can't help but turn chaos into faces. On Earth, it's useful, spotting predators in the brush. On Mars, it's misleading, spotting people in piles of dust. Yet the face on Mars endures, not as science, but as symbol. It represents our longing for neighbours in the cosmos, our refusal to accept loneliness. And maybe that's the real point. Even when Mars gives us silence, we project our own voices onto it. But if the face was just shadows, what about the grander claim that Mars once hosted an actual civilization? To that, we now turn, a collision of science, conspiracy, and stubborn human imagination. The face on Mars was only the beginning. Once people decided that Cydonia held secrets, every nearby hill, every oddly shaped ridge became a clue. Enter the so-called Cydonia pyramids. A handful of triangular mesas naturally eroded over eons, but to eager eyes they looked like ancient Egyptian pyramids transplanted onto the Martian desert. Some enthusiasts even mapped out their positions, claiming they lined up like the stars of Orion's belt. Yes, the same constellation linked to the pyramids at Giza. The cosmos, it seemed, was full of real estate developers with a flair for symmetry. Authors like Richard Hoagland championed the idea, weaving grand theories of a vanished Martian civilization. He argued that NASA was deliberately downplaying the evidence, while his book sold in the hundreds of thousands. To him and his readers, the Cydonia region was no accident. It was a lost city, a smoking gun. And the fact that NASA scientists were rolling their eyes only made the theory juicier. After all, isn't denial the first step in a cover-up? But geology is a buzzkill. Mars has been shaped by wind, impacts and erosion for billions of years. Put enough craters and mesas under a slanting sunset, and sooner or later one will look like a pyramid. Studies of the D&M pyramid, named after its discoverers Di Pietro and Molinar, showed it wasn't cut stone blocks but fractured rock. The angles weren't perfect. The symmetry collapsed under close measurement. In short, it was a natural hill that just happened to strike a dramatic pose. Yet, let's be fair, the people who saw cities and monuments weren't stupid. They were imaginative. They were doing what humans always do, connecting dots, building stories, searching for meaning in the void. If Earth has ancient civilizations and monumental architecture, why couldn't Mars have had its own? The what-if was too delicious to let go. Even Carl Sagan addressed the frenzy. In his book, The Demon-Haunted World, he dissected the face on Mars craze as an example of pareidolia and wishful thinking. He warned that extraordinary claims demand extraordinary evidence, a phrase that deserves to be tattooed on every conspiracy theorist's forehead. But for all the debunking, the allure remained. People wanted Mars to be haunted. They wanted pyramids, faces, cities, because it made the universe feel less lonely. Skepticism crushed the specifics, but the romance of the idea survived, and just when scientists thought they'd settled the case, Mars threw up a new challenge, odd little shapes in rover photos that reignited the whispers of life and mystery. Here's the thing about Mars. It's a world made of rocks, and rocks are tricksters. They break, erode, scatter, and, if you squint just right, they start to look familiar. A woman in robes sitting on a cliff, a mouse darting across the sand, even a helmet from Star Wars. These are all discoveries people have claimed after zooming in on blurry rover images. NASA uploads raw photos from rovers like Curiosity and Perseverance almost daily, and the internet pounces. Within hours, forums and YouTube channels are buzzing. Alien bones on Mars? Fossilized lizards spotted near rover wheels. It's the same pattern as the face on Mars, but democratized. Now every internet user is a would-be archaeologist of alien ruins. Psychologists nod knowingly. It's still pareidolia, the human brain's obsession with finding patterns. We're wired for it. Faces in clouds, monsters in shadows, and now statues on Mars. On Earth, it once kept us alive. Better to mistake a bush for a lion than the other way around. On Mars, it just keeps Reddit threads alive. Scientists, of course, remain calm. They explain that the woman on a cliff is a rock shard a few inches tall, not a towering statue. The mouse is a pebble the size of your thumb. Without scale, shadows can play cruel tricks. But explaining rarely kills the romance. If anything, the corrections add fuel. See? NASA is lying to us again. And there's the cultural piece. Humans have always filled the unknown with stories. Once we filled maps with sea serpents. Now we fill Mars with lizards and statues. It's not just superstition, it's comfort. A dead, silent world is depressing. A world with hidden life, even fossilized or sculpted, feels like company. In a way, these viral Mars discoveries tell us more about ourselves than about the planet. They reveal our loneliness, our need for cosmic neighbours, our refusal to stare into the abyss and accept only silence. The real Mars may just be dust and basalt, but in our collective imagination, it's haunted by the ghosts we long for. Yet, not all speculation is mere fantasy. There's another idea, more ambitious, more audacious. Not that Mars had life, but that it could host life again. Not Martians building pyramids, but us, turning the red planet green. Enter the dream of terraforming Mars. Terraforming. The word itself sounds like science fiction. To shape a world. To take a frozen desert and coax it back into something alive. For Mars, the idea is irresistible. What if we could turn that cold red wasteland into a second Earth? A backup planet. A cosmic insurance policy. No one leaned into this fantasy harder than Elon Musk. His proposal? Nuke the poles. Seriously. Drop nuclear bombs on Mars's icy caps, vaporize the frozen carbon dioxide, and unleash a greenhouse effect to thicken the atmosphere and warm the planet. A plan that sounds less like a scientific paper and more like the plot of a comic book villain. Scientists raised eyebrows, and a few laughed out loud. Even if you detonated thousands of bombs, the numbers don't add up. You'd release some CO2, sure, but not nearly enough to create breathable air. Mars simply doesn't have the reserves. Studies show that even if we mined every bit of CO2 from its rocks and soil, the atmosphere would still be thinner than standing on Mount Everest without oxygen. Romantic, maybe. Survivable? No. And even if you managed to puff up the atmosphere, Mars would just let it slip away again. Remember the missing magnetic field? Without it, solar wind strips gases into space. It's like trying to inflate a balloon with a hole in it. The universe is patient and Mars leaks. That hasn't stopped dreamers from imagining workarounds. NASA scientists once floated the idea of building a giant magnetic shield and parking it at a stable orbit point between Mars and the Sun. A colossal force field to block solar wind, protecting Mars's atmosphere like Earth's magnetic bubble does. It sounds wild, but at least it's physics, not pyrotechnics. Then there's the biology approach. Scatter genetically engineered microbes across Mars to churn out oxygen the way cyanobacteria once did on Earth. In theory, after a few millennia, they might create a breathable atmosphere. In practice, microbes need warmth, liquid water, and sunlight. 3 things Mars is stingy with. And let's not forget the ethical dilemma. What if Mars already harbours microbial life, hiding deep underground? Do we have the right to bulldoze an alien biosphere just to make condos for Earthlings? Terraforming could be less about creating life and more about destroying it. Still, the dream clings to us. Because in imagining Mars remade, we're really rehearsing our own survival story. It's not just about the red planet. It's about Earth, about whether we can fix the world we have before we go tampering with another. But let's get practical. Since we can't transform Mars overnight, what would life actually look like for the first colonists? The pioneers who dare to trade blue skies for a red horizon. Picture it. You're one of the first humans to step onto Mars. The ground crunches beneath your boots. A rust-coloured desert stretching to the horizon. The gravity is lighter. Every step feels like a bounce. The air? You can't breathe it. Outside your suit, it's 95% carbon dioxide, thin enough to suffocate you in seconds. Your world is a bubble of oxygen strapped to your back, and the hiss of your regulator is the only sound besides your heartbeat. The colony begins small. Inflatable domes or underground habitats carved into the Martian regolith. Inside, pressure is Earth-like, temperatures are controlled, and oxygen is manufactured by splitting water molecules, if you can get enough water. Martian ice deposits, especially near the poles, become treasure troves. Melting, filtering, recycling, every drop counts. Wastewater isn't waste, it's tomorrow's coffee. Food? Forget steak dinners. Colonists live on hydroponic farms. Leafy greens, potatoes, maybe a tomato or two if you're lucky. In fact, growing crops on Mars has already been tested in labs on Earth, using soil simulants spiked with nutrients. Yes, Martian potatoes is more than just a Matt Damon meme, it's a survival strategy. The real danger isn't hunger though, it's radiation. Without a magnetic field or thick atmosphere, Mars is bathed in cosmic rays. Long exposure means cancer, organ damage, and DNA mutations. The solution? Live underground, or pile meters of soil over your habitat for shielding. Outside excursions, spacewalks on the Martian surface, would have to be short, cautious, and carefully timed. Then there's the psychological battlefield. Imagine living with 100 people in a bubble where the nearest grocery store is 55 million kilometers away. Communication with Earth has a 10 to 20 minute delay each way. No real-time conversations with family. Every message feels like shouting into a canyon. Loneliness presses in. Cabin fever lurks. History from polar stations and submarines suggests conflicts will arise, not from cosmic dust storms, but from someone chewing too loudly in the cafeteria. Yet, there's also wonder. Walking under twin moons. Phobos racing across the sky. Deimos drifting lazily behind. Watching a sunset that turns the Martian sky blue, the opposite of Earth. Standing before canyons so vast they make the Grand Canyon look like a crack in the sidewalk. These moments remind colonists why they came, to witness the extraordinary, to be the first. But here's the paradox. For all the danger, the cost, the psychological strain, people will still line up to go. Because Mars represents something Earth can't offer anymore, the thrill of the frontier. It's the same spirit that drove humans across oceans, into jungles, up mountains. Mars is the next blank page, and despite the risks, someone has to write the first line. So the real question isn't whether people can live on Mars, it's whether we should. Is Mars our salvation, or a distraction from saving the planet we already have? So, should Mars be humanity's plan B, or is it just a very expensive distraction? That's the argument simmering beneath every TED Talk, every SpaceX announcement, every late-night YouTube rabbit hole. On one side, you've got the optimists. They say Earth is fragile, and history proves it. Asteroids, supervolcanoes, climate shifts. Our planet has been sucker-punched before. Why gamble everything on one basket when the universe is full of others? Colonizing Mars, they argue, is survival instinct. It's the cosmic equivalent of saving your work on a second hard drive. On the other side, the realists. They point out that we already live on the best planet in the known universe. Earth has breathable air, liquid oceans, and a magnetic field that shields us from deadly radiation. And even with all that, we're struggling to keep it habitable. If we can't manage this paradise, what makes us think we can manage a frozen desert that actively tries to kill us? The debate isn't really about Mars, it's about us. Do we face the mess we've made here, or do we dream of starting fresh elsewhere? It's easier to fantasize about new worlds than to fix the one under our feet. Terraforming Mars might be centuries away, if it's possible at all. Restoring Earth's ecosystems? That's possible right now. The problem isn't physics, it's politics. Yet Mars still calls to us, not just as refuge, but as a mirror, a warning. Billions of years ago, it may have been warm, wet, alive with possibilities. Then it lost its shield, its air, its rivers. Now it's a barren graveyard. Some scientists whisper that Mars is a preview of Earth's future, should we keep neglecting the delicate balance that sustains us. And maybe that's the point. Mars isn't a backup drive, it's a cautionary tale, a reminder of how easily a living planet can die. Still, the story doesn't end there, because while the future is uncertain, the present is buzzing. Right now, across deserts, launch pads, and laboratories, humanity is racing to crack Mars's secrets. The next chapter isn't about speculation, it's about the missions unfolding as we speak. Right now, Mars is the hottest piece of real estate in the solar system, not because anyone wants to build condos, but because every major space agency wants a stake in its secrets. NASA, ESA, China, India, even the UAE, all have machines orbiting or rolling across the red planet. It's not science fiction anymore, it's an interplanetary science fair, and the prize is history itself. NASA's Curiosity rover, the Veteran, has been trudging across Gale Crater since 2012, more than a decade old, still drilling rocks, still beaming selfies back home. It's the rover equivalent of that one guy at work who never retires. Then there's Perseverance, the flashy new kid, which landed in 2021. Its mission? to hunt for traces of ancient life and stash samples in little metal tubes, waiting for a future spacecraft to bring them home. If that plan works, it'll be the first time Martian dirt and rock are held in Earth's labs. Imagine the headlines. Scientists discover Martian fossil in sample tube Cyclone 14. And Perseverance didn't come alone. It brought a buddy, Ingenuity, the first helicopter to fly on another planet. Barely 2 kilos of metal and rotors, yet it proved that flight was possible in Mars's whisper-thin atmosphere. What started as a tech demo turned into a full-time scout. Every hop it takes is history being rewritten. The Wright brothers, but 225 million kilometers away. Meanwhile, China's Zhurong rover made its mark in 2021, showing that Beijing wasn't content to just watch NASA hog the spotlight. It confirmed geological evidence for ancient water and probed subsurface structures with ground-penetrating radar. Europe, for its part, had a setback when its Rosalind Franklin rover was delayed. But the plan remains: drill deep into Martian soil, where radiation hasn't fried potential organic traces. Even smaller players joined the race. The UAE's Hope orbiter now circles Mars, studying its atmosphere with a kind of elegance, not chasing rocks, but asking how the climate shifts, how gases slip into space. India's Mangalyaan 2 proved a nation could reach Mars on a shoestring budget, showing that this planetary obsession isn't confined to superpowers. So what's the common thread here? Curiosity, rivalry. The same instincts that once sent ships across oceans now drive rockets across planets. And while agencies will talk about international cooperation, let's be honest, it's also a race. Whoever brings back the first Martian fossil, whoever proves life existed there, wins more than bragging rights. They win a new chapter in human history. The question is, when those samples arrive, will they confirm our wildest hopes, or crush them? The dream, of course, is the Mars sample return. Imagine it. A small tube of rock, drilled by Perseverance, sealed tight and left on the dusty ground. Years later, another robot swoops down, scoops it up, rockets it into orbit, and then, this is the hard part, hands it off to a spacecraft bound for Earth. It's like an interplanetary relay race, with robots passing batons across millions of kilometers. If it works, scientists back home will have the first pristine chunks of Mars in their labs. No more fuzzy rover images, no more guesswork from orbit. They'll be able to slice, scan, and scrutinize with tools a rover could never carry: electron microscopes, mass spectrometers, isotope analyzers. If there's even a whisper of ancient life preserved in those rocks, fossilized microbes, organic molecules, anything, it'll be found here on Earth. NASA and ESA have penciled in the mission for the 2030s, though the timeline wobbles with every budget hearing. China, never one to sit quietly, has announced its own sample return plans for roughly the same decade. Suddenly, the red planet feels less like a lonely world and more like a finish line, with nations sprinting toward it. But while robots do the heavy lifting, there's still a place for daring little experiments. Perseverance carries Moxie, a toaster-sized box that did something extraordinary. It made oxygen out of Martian air. Not much, enough for one astronaut to breathe for a few minutes, but it proved the concept. If scaled up, machines like Moxie could supply oxygen for rockets and habitats, cutting the supply chain to Earth. It's the first baby step toward living off the land, Martian style. Then there's Ingenuity, still buzzing. Still proving that even in a world where the air is thinner than the top of Everest, human ingenuity, pun intended, can find a way to fly. Each of its hops scouts safe paths for Perseverance, but symbolically, it does more. It whispers that flight, freedom, and exploration are not Earth's monopoly. So, we're laying the groundwork. But let's not kid ourselves. This is still the prologue. The real story, the one history books will linger on, begins the day humans themselves step onto Martian soil, and that moment, it may arrive within your lifetime. NASA likes to circle dates in pencil, not ink. Still, the 2030s are whispered as the decade when humans might finally set foot on Mars. It won't be a stroll in the park, it'll be the most dangerous camping trip in history. Picture this: months trapped inside a spacecraft the size of a studio apartment, radiation seeping through the walls, your body slowly weakening in microgravity. And then, after the long voyage, the hardest part hasn't even started yet. You still have to land. Landing on Mars is notorious. Engineers call it the 7 minutes of terror. The atmosphere is just thick enough to cause heat and turbulence, but too thin to slow a spacecraft safely with parachutes alone. It's like trying to land in molasses that suddenly turns into smoke. For rovers, NASA has used everything from giant airbags to rocket-powered sky cranes. For a crewed ship weighing tens of tons, the solution isn't fully solved yet. Suppose they make it down. The first human footprints on Mars will echo like Neil Armstrong's, but the challenges multiply immediately. Habitats must be airtight, shielded against radiation, and stocked with food and water. Life support systems will recycle every drop, every breath. Dust storms could blanket solar panels. Suits will need constant maintenance, because Martian dust is not just dirty, it's toxic. Laced with perchlorates that can wreck human thyroids. One careless leak, one broken valve, and the colony becomes a coffin. And yet, people will go. Why? Because history shows that risk has never stopped us. From Polynesians sailing into endless oceans, to polar explorers vanishing into the ice, humans have always gambled comfort for discovery. Mars is just the next chapter in that long, reckless, glorious tradition. The first Martian pioneers will be remembered not just for what they endured, but for what they symbolized: humanity becoming a multi-planet species. A phrase tossed around in press conferences, sure, but one that carries existential weight. If we spread to 2 worlds, the odds of extinction shrink. Civilization gains a backup. Humanity's story lengthens. But it won't be romantic. Colonists will struggle. They'll feel the crushing isolation of knowing Earth is 225 million kilometers away. That no rescue ship can arrive in time if something goes wrong. They'll look up at a sky where the stars shine unblinking, and Earth is just a pale blue dot, hanging there like a memory. And perhaps that's the ultimate paradox. We reach Mars to survive, but the very act of living there will remind us just how special Earth is. The green forests, the oceans, the breathable air. Mars is the dream, but Earth is the miracle. So let's circle back to the question that started it all. Is Mars a dead Earth, or Earth's possible future? The evidence is sobering. Billions of years ago, Mars had rivers, lakes, maybe even oceans. It had a thicker atmosphere, a magnetic field, and a climate that might have been mild enough to cradle life. Then came the great unravelling. The core cooled, the magnetic shield collapsed, and the atmosphere was stripped away. Water vanished or froze beneath the soil. Mars didn't explode, it withered. That story feels uncomfortably familiar. Climate collapse, mass extinction, a planet losing its habitability. When we study Mars, we're not just peering into an alien past. We're glimpsing a possible earthly future. In a few billion years, when our own core cools and our shield weakens, Earth too could be scoured by solar winds, left barren under an empty sky. Mars is a ghost, yes, but a ghost that looks suspiciously like us. And yet, there's another possibility. Mars could be a second chance. If humans manage to settle it, even in domes and bunkers, not under blue skies, it will mean something profound. That life, stubborn and reckless, refused to stay caged to one planet. Mars could be a classroom, teaching us survival, resilience, and humility. And maybe, just maybe, we'll learn to treat Earth better in the process. Because nothing makes you appreciate home like moving to a place with 100-degree winters and toxic dust. But here's the twist. Whether Mars is a warning or a promise depends entirely on us. If we treat Earth like a disposable prototype, Mars will not save us. It will simply become a colder grave. If we treat Earth as irreplaceable, and Mars as an experiment in endurance, then maybe both worlds gain new meaning. So, was Mars once alive? Did it cradle microbes in its ancient seas? We don't know yet. Will Mars one day cradle us? That too is uncertain. But in chasing these questions, we're really asking something deeper. What does it mean to be human in a universe that mostly doesn't care whether we live or die? And that's why the red planet holds us captive. It isn't just about rocks or rovers, it's about mirrors. Looking at Mars is like staring at two reflections at once, one of what we might become if we fail, and one of what we might become if we endure. Which leaves us with a final unsettling thought. Maybe Mars isn't asking us if life ever existed there. Maybe it's asking us whether life will continue here. And that perhaps is the strangest gift Mars offers us: perspective. When we stare at its red horizon, we're not really searching for aliens or pyramids. We're searching for ourselves, for proof that life can endure in a universe that seems built for silence. Every rover, every orbiter, every drill into Martian soil is part of a long, slow interrogation. We're asking Mars, what happened to you? Could it happen to us? And if so, what are we going to do about it? The irony is delicious. We've spent billions to study a frozen desert millions of kilometers away, while ignoring the forests, rivers, and oceans of our own planet. Mars, in that sense, is a cosmic therapist. It holds up a cracked mirror and asks, "Are you sure you want to end up like me?" But beyond the warnings and metaphors, there's also the allure of wonder. Imagine the first child born on Mars, a human who has never breathed Earth's air, never seen an ocean, never walked under blue skies. What stories will they tell? Will they feel exiled or privileged? Will they look at Earth as home or as myth? And think about the culture that would grow there. Colonists sharing meals in cramped habitats, inventing new rituals to mark time in a world where days are 24 hours and 37 minutes long. The holidays might revolve around dust storms or the rare sight of Earth glowing in the night sky. Human imagination will adapt, as it always does, and Mars will cease to be the other world and become simply home for those who endure it. So, is Mars dead? In one sense, yes. It's a cold, barren rock. But in another sense, it's very much alive, at least in our minds. It has inspired poets, conspiracy theorists, engineers, dreamers. It has forced us to wrestle with questions about survival, identity, and meaning. Mars may never have had its own civilization, but it might just help ours survive a little longer. And that's why the obsession never dies. Not because Mars promises easy answers, but because it keeps throwing the hard questions back at us. So the next time you see a headline about Martian microbes, or pyramids in Sidonia, or Elon Musk tweeting about nuking the poles, remember, Mars is more than a planet. It's a stage, a mirror, a challenge. It's the place where science and imagination collide, and where humanity rehearses its future. And maybe, just maybe, one day we'll look back at these early debates, these rovers and rock samples, and laugh. Because by then, someone will be watching a Martian sunset through the glass of a dome, telling their child, "Once upon a time we only dreamed of living here."